Okay, welcome to the second video about evaluating functions. In this case, we're not just plugging in one numerical value like finding f of 2. In this video, you're going to see things like this with variables being plugged into a function. Specific, I guess, with variables plugging in instead. So this is just one example of. In our first example, we want to find f of x plus 3. And all that means is it's the same idea. We're just going to be plugging in x plus 3 everywhere there's an x in the function f, instead of just plugging in like 3 only. So we're just plugging in something larger, a binomial specifically. So this will look like -2, and then we're going to plug in x plus 3 here. That gets squared, plus, again, x plus 3, and then a -1. Okay, we'll say that the parentheses are necessary here because we're squaring something. However, they're not necessary here, but it's just a good habit to get into to use parentheses. Okay, let's just do all blue now. So we're going to use order of operation, PEMDAS. We're going to first square x plus 3. Now, what does squaring x plus 3 mean? It does not mean x squared plus 9. Don't do that. I'm going to do this little piece here off to the side. In case you need a reminder, x plus 3 times x plus 3. That's what it means, multiplying by itself. And then we are going to FOIL or just multiply, right? So x times x times 3, 3 times x, and 3 times 3. So this ends up being x squared plus 6x plus 9. So that's where we're going to get that from. All right, so going back to our original problem, we have the -2, and then in here I'm going to write what it is. It's x squared plus 6x plus 9. And then I'm just going to drop the parentheses here. And then in our next step, we can distribute the -2 through these 3 values. A lot of negatives. And then I'm just going to combine those two in this step as well. All right, now we can combine like terms. There's only one quadratic term. And there's a linear term here and a linear term here. So we'll get -11x. And then there's a constant and another constant to give us -16. Okay, our next example is going to be still it's pretty much the same except for a 3, we're having an h here. And if you're wondering why you see this quite often in classes before calculus, it's because this is an idea that is pretty pervasive in the limits part of calculus, limits and derivatives. So we want you to just see it before you get to calculus. All right, so we're going to plug in x plus h, again, everywhere there's an x, that's the idea. And again, unnecessary parentheses here, but you should still use them. I recommend that. Okay, so we plugged in x plus h everywhere. And again, off to the side, I'm going to write out this piece right here. If you don't need to do this, then don't. But I just want to show you what it means. Again, squaring something means multiplying it by itself. It does not just mean it's x squared plus h squared. All right, so we have to distribute the x. So we'll get x squared plus xh. And then we're going to distribute the h through. And instead of writing hx, I'm just going to write xh again, just to keep them the same. Multiplication is commutative, so you can write them in either order. And then we have like terms here. So we're going to get x squared plus 2xh plus h squared. So that's what we end up getting for that. So we'll go back to our original. And this is x squared plus 2xh plus h squared plus x plus h minus 1. We'll distribute the -2. And from here, we just want to see if we have any like terms. It seems pretty weird, and it is kind of. Again, before you get to calculus, you just stop here, but it'll make more sense once you hit calculus. However, there's no other x squared terms, no other xh, no other h squared, no other just plain x, just plain h or no other constants. So this is actually our very strange final answer. And our last example is probably the easiest one. We're going to use our g function now over here, and we only have to plug in one time and nothing's squared, so it's a little easier. So we're going to have the 3 in the numerator, a 4, and then x minus 2. And so when we distribute, which you could leave it like that if you wanted, but let's distribute the 4 through. And there we go. We can't cancel anything. If we could cancel, we'd be able to do it here, but 3/4 is not able to be simplified. So our final answer is this rational function here.